Okay, this week is going to be cram-packed with some awesome stuff. First of all, we get to see the new gorgeous pictures from the HiRISE, the instrument attached to the Mars Reconnaissance Orbiter. Beautiful pictures and some great music. Also, they finally announced the development of the Europa Orbiter. So check it out. There's some concept images, and also check out to find out how you can get involved in the Europa Orbiter name contest with Planetary Television. So you can be able to get your name out there, get recognized. We're introducing our newest staff member. It's going to be Andrew Reeves, who's going to be taking care of our Mars weather reports, and he's going to be able to get his hands into some of the other segments that's going on with space exploration. Also, I'm going to be bringing you the newest updates for the Mars exploration rovers. Everything covering from April 8th up to April 16th, which is actually today, so you can get the newest stuff. Also, Cobert, the Cobert report, goes to space. He's not paying $10 billion to go to space, but he's going to space. Find out. It's pretty funny. We got the newest images for the from the Cassini spacecraft. I've tightened some great, awesome pictures, but in a couple days, or I think it's actually today or tomorrow, Cassini's doing a flyby of Titan. So you're actually I'm going to have a special segment of Titan, and allow you to be able to see these beautiful pictures later on this, hopefully in a couple days when they release it. Also, we're going to be introducing a trivia contest. Trivia contest is going to be basically off of everything space exploration. So if you want to get involved, wait to the end, check it out, and see what you need to do to send off your answers and get yourself recognized on any of the Planetary Television segments. Also, to tell you now, this is going to be like one of the longest segments we've ever had. Mainly because it's 20 minutes long. We've added in all these bunch of different videos and features and stuff like that. So it's going to be a big segment. It's actually going to be 2 parts. It's 20 minutes long, 10 minutes each, unfortunately. And so if you want to make sure you check out the second part, which is going to be a video response to this. So don't miss on the whole second half of this show. So check it out. Make sure you look at it. If you have any questions with anything that you see, leave a comment on either of the video submissions and let me know, and I'll answer them next time. Next week. So sit back, get yourself ready with a nice drink, and get ready for a magic carpet ride.
We're sitting on top of the story of the century here.
On April 9th, the University of Tennessee's Earth and Planetary Science Department hosted a curriculum led by Bob Pappalardo of JPL to discuss the recently selected Europa Jupiter System Mission, or EGSM. Pappalardo began by discussing our current post-Galileo understanding of Europa. It is thought that the current ice shell is 60 to 100 million years old. Due to a small amount of torque applied to the Jupiter-facing side at its closest point in its orbit, caused by tidal forces from Jupiter, the outer shell rotates at a slightly asynchronous rate, a ballpark number given as one extra rotation for every 10 times the 6th orbits. This conclusion is based on observations of the positions and orientations of linear features on Europa. The stresses on the ice crust that made those linear features seem consistent with Europa having picked up about a third of a rotation since the ice shell formed. Galileo captured this view of Europa on its 14th orbit of Jupiter on March 29, 1998. The image is a mosaic of 5 different pointings. The filter used for this image cover a broader range of spectrum than human eyes can see. Galileo was 143,000 kilometers from Europa when it took this image, at a phase angle of 77 degrees. Image scale is 1.5 kilometers per pixel. The radar on the proposed Europa orbiter should be able to penetrate the hard, brittle surface layers of ice and map out of the layer of ice below. Unfortunately, these softer regions are more opaque to radar than are the brittle other regions, so it may not be able to see down into the local ocean. However, if some of the thin ice models that some scientists favor prove correct, and the ice shell is only 2 to 3 kilometers thick, then the radar system should see right through it. So in other words, it should settle the thick ice versus thin ice debate once and for all. However, some with a thick shell, we might have some windows through which to look directly into the ocean. Pappalardo stressed that if they had to cut the payload to just one instrument, not that this is being considered, he was trying to make a point. It should be the radar. The imaging system is also impressive. It will contain global multispectral coverage in stereo at 100 meters per pixel. It will have a high-resolution camera with a resolution from orbit of 10 meters per pixel, plus a strip down to the center at 1 meter per pixel. The plan is to design a system that could function as a framing camera during the early part of the mission, during which it is conducting flybys of Jupiter's moons. However, in orbit it will act as a linear array using orbital motion to scan the surface of Europa. Given that the audience included a number of geologists, some interesting questions came up. First of all, several people noted that the features attributed to pulling apart due to tension don't have corresponding compression features elsewhere on the moon. Pappalardo acknowledged that this is an ongoing problem, although our global coverage of Europa isn't good enough to be sure that the compression features don't exist. Another issue that geologists noted that some of the magnometer observations attributed to an induced magnetic field via the global ocean may actually be due to the psychoelectric forces, electricity generated when a mechanical force is applied from tidal strains on the rocky interiors. All in all, it was a very interesting and informative presentation. Pappalardo was headed to Vienna, Austria to go to the meeting on planetary projection requirements for the mission. Now it would be interesting to see how planning unfolds in the coming months.